Example C, we're going to solve the following equation using trial and improvement. Remember, that means you're finding the solution value of x, which will give you the target number. So the first thing we do as usual is we rule out our trial and improvement table with our 4 columns: solution value of x, chosen x values, left hand side of the equation, which in this case is 4x squared minus 28, and then we have our output column. So we always start by choosing 2 consecutive whole number x values such that when we sub them into the left hand side of the equation, one of them will give us an output which is smaller than the target number, and the other one will give us an output which is bigger than the target number. Now this time they have not told us what x value to start with, so we have to come up with that ourselves, and it may not necessarily be 1. It could be bigger than 1. So because the target number is quite large and we're subtracting here, my suspicion is that we're going to have to start with a higher x value than 1. Now let's say, for example, we chose x as 5, right? 5 squared is going to give you 25. Multiply that by 4, you get 100. And 100 subtract 28 is going to leave you with 72, which is just smaller than the target number. Now, if you were to chuck 6 in, okay, use my calculator. If we chuck 6 in, we're going to get 4 bracket 6 squared minus 28, and that's going to give you 116, which is bigger than the target number. So the starting value is 5. So we're going to start with x is 5, and we're going to chuck it into the left hand side. Again, make sure you use brackets when you sub a number in that has a power. And again, you can type that on our calculator. We did it mentally there at the start, but we'll type it in again. So that's going to give you an output of 72, which is smaller than the target number. So the next whole number value of x we're going to choose is 6, and we're going to chuck it into the left hand side. And again, go to your calculator and type it in carefully. That's going to give us 116, which is bigger than the target number. So that's actually the hardest bit. It's trying to get 2 consecutive x values such that when you sub 1 into the left hand side, your output is smaller than the target number, and then the next x value you sub in to the left hand side, your output's bigger. So you'd be wasting your time starting with x is 1, because you'd find that 1 would give you an output that's smaller, so would 2, so would 3, so would 4. It would take you to get to 5 and then 6 before you would see an output that's smaller and an output that's bigger. Okay, so we've now established the gap that the solution value lies between. So the solution value, in other words the value of x that gives you the target number, must lie between 5 and 6. So we have to shorten or narrow this gap and make it smaller each time. So we now look at the x values at each end of the gap. You'll notice that they have the same number of digits and their last digit differs by 1. So the next x value you pick will be halfway between them. So we now pick 5.5. And we then sub that into the left hand side of the equation. And again, go to your calculator and type it in carefully. That's going to give us an output of 93. So clearly 93 is still bigger than the target number. So every time we get a new output, we have to then recalculate the gap. So the gap used to be between 5 and 6. When we chucked 6 in, our output was bigger, but now when we chuck 5.5 in, our output's bigger. So we're now getting rid of 6 because 6 and 5.5 give the same result, bigger. So get rid of 6, so the new gap is between 5 and 5.5. So the gap is getting smaller. Now, the next x value we pick, again, depends on what the x values are at each end of the gap. Now, the x values at each end of the gap do not have the same number of digits. This guy's only got 1 and this guy's got 2, so we can't go halfway. So what we do then is we look at the corresponding output values for those two x values, and you look for the output value that's closest to the target number. Now the target number is 84, so 72 is 12 away and 93 is 9 away. So clearly this output 93 is closer to the target number than 72. So the next x value we pick has to be between 5 and 5.5, but it has to be closer to 5.5. So we're going to choose 5.4. And again, we're now going to chuck that into the left hand side. Again, we can go to your calculator and type it in carefully. Hit our SD button, that's going to give us 88.64. So our output is still bigger than the target number. So again, we have to recalculate the gap. So the gap used to be between 5 and 5.5. When we chucked in 5.5, the output was bigger, but now when we chuck in 5.4, the output is bigger. So the gap now is shrunk again. It's now between 5 and 5.4. Now, to decide what the next x value is that we pick, we look at the x values at each end of the gap. The x values at each end of the gap do not have the same number of digits, so we can't go halfway. So again, we look at the output values for each of these x values, and we look for the output value that's closest to the target number. So clearly 88.64 is closer to the target number than 72 is. So the next x value we pick has to be between 5.4 and 5, but has to be closer to 5.4. So we have to pick 5.3. So again, we're going to chuck 5.3 into the left hand side. And then type it into your calculator once more. Hit our SD button, and that's going to give us 84.36, which is just slightly bigger than the target number. So we have to recalculate the gap again. So the gap used to be between 5 and 5.4. When we chucked in 5.4, the result was bigger, but now when we chuck in 5.3, the result is bigger. So the gap is now between 5 and 5.3. So that's where the solution value lies at the minute. Now again, the next x value we choose depends on what the x values are at each end of the gap. So the x values at each end of the gap do not have the same number of digits, so we can't go halfway. So again, we look at the output values for those x values, and you'll see that the output value of 84.36 is closer to the target number of 84 than 72 is. So the next x value we pick has to be between 5.3 and 5, but has to be closer to 5.3. So we're going to pick 5.2. And then we're going to chuck 5.2 into the left hand side. And then again we go to your calculator, type it in very carefully. And this time we get 80.16. Now, the output value is now smaller than the target number. So again, we recalculate the gap. So the gap used to be between 5 and 5.3. When we chucked in 5, the output was small, but now when we chuck in 5.2, the output is small. So the gap is no longer between 5 and 5.3, it's now between 5.2 and 5.3. Now, the next x value we choose depends on what the x values are at each end of the gap. So the x values at each end of the gap have the same number of digits and their last digit differs by 1. So we now pick an x value that's halfway between them. So halfway between 5.2 and 5.3 is going to be 5.25. And there's some good news. This is going to be our last step because we have to give our answer to 1 decimal place. So the moment you're working with an x value with 2 decimal places, you know there's going to be no more calculations. So again, we chuck 5.25 into the left hand side. Again, we go to our calculator, type it in carefully. And that's going to give us 82.25, which is smaller than the target number. So again, we recalculate the gap. So the gap was between 5.3 and 5.2. When we chucked in 5.2, the output was smaller, but now when we chuck in 5.25, the output is smaller. So the gap is shrunk again. It's now between 5.3 and 5.25. So we now stop because we have an x value with 2 decimal places. So we now write down the final gap that the solution value lies in. So the solution value lies between 5.3 and 5.25. So we just copy it down. 5.3 and then 5.25. So solution value lies in there. So what we're going to do now is write down all the x values we can think of to 2 decimal places that lie between 5.25 and 5.3. So start from the smaller value in the gap. So after 5.25 we're going to have 5.26, 5.27, 5.28, 5.29. Now what you'll notice is all those little red values in the gap, if we were to round them all to 1 decimal place, they would all round to 5.3. So they all round to 5.3 to 1 decimal place. Now, if all the values between 5.25 and 5.3 round to 5.3 to 1 decimal place, and the solution value also lies in here, then the solution value must also be 5.3 to 1 decimal place. So our final answer, the solution value is x equals 5.3, and that is the 1 decimal place. Now again, what that means is we have found the solution value to 1 decimal place, which gives us the closest output to the target number. So what you can do now is go back to the table and look at all the x values to 1 decimal place, and you'll notice that the one that gives you the output value closest to the target number is 5.3. Because look, 5.5 gives you 93, 5.4 gives you 88.64, 5.3 gives you 84.36, 5.2 gives you 80.16, and yeah, so if you look at those 4 outputs, the output there that is closest to 84 is this one, 84.36, and that corresponds to an x value of 5.3.